All right, now that we know what an ellipse is, let's talk about how to graph one. So we're going to go through these 4 examples. On the first one it says, draw a graph of the given ellipse, labeling the center, vertices, and major axis. So again, we're going to find the center. That's the thing that we need to start graphing our ellipse here. But also we're going to look at the vertices, and then it wants us to label or recognize the major axis. So here's our equation. Again, like we talked about on the front, we look for the largest value on the bottom, and that tells us that this must be the a squared, and a is always related to that major axis. Because this largest number is underneath the x term, that means that this is elongated horizontally. Okay, so we know it's going to look something like that. And we know that if a squared is 64, then a must be equal to the square root of 64, which is 8. Remember, that represents the distance from the center out to a vertice, so we know that that's going to be 8. Again, if that one's 8, then we're looking at this other one. This must be our b squared. So if b squared is 9, then b is equal to the square root of 9, which is 3. So again, if this is our ellipse, then from the center on our minor axis out to the co-vertice, that would be 3 units. Okay, so if we can figure out where the center is and then use those 2 values, that would help us draw our ellipse. So the center, again, comes from the HK. So if I want to find the center, I look up here at my x value. It's adding 3, so I'm going to put -3 inside my center. The y value is not adding or subtracting anything, which means my k value must be 0. Okay, so let's graph this. We've got enough information, so we come over and we graph the center, which is -3, 0. So we're looking at a center right there on the x-axis. Our a value is 8, so we know that we're going to count 8 units to the right. So 1, 2, 3, 4, 5, 6, 7, 8 over here puts me at 5, and I'm going to label that so I remember. And then we're going to go 8 units to the other direction. So left, 1, 2, 3, 4, 5, 6, 7, 8. Okay, and that's out at -11. So notice we've created just a symmetric piece. That right there is our major axis. Okay, so normally we don't have to label that, it just asked us to, so we're going to label that major axis. Then we use our b value to help us graph the other points. So b is equal to 3, so we're going to go 3 up vertically from the center. So now we're up there at 3, and we're also going to go down 3. Okay, and then you're going to do the very best you can. I'm going to graph this maybe in red or purple. And you're going to just draw almost like you're drawing 2 parabolas. Okay, it's a little harder than it looks, but do the best you can. And you're going to connect the pieces. Okay, that's our ellipse. The second part says determine where the foci of the ellipse would be and draw those in also. Now remember, the foci is the distance, I'm going to draw a little picture, from the center to the foci here and here. So really what you need to do is you need to find that c value, and we'll do this more in video 3. But just as kind of an example, to find that c value, you would do c squared is equal to the a squared minus b squared. So you use what you know, and we know a and b. So to find the c value, I would take my a squared, so that's like 8 squared, minus my b squared. So 8 squared is 64 minus 9, that would be 55 if I simplify that. And to solve that, you'd need to square root. So notice that c is equal to the square root of 55. Now, if I was going to plot that on the graph, I probably would want to write that as a decimal. The square root of 55 is about 7.4. Normally, you would not convert that to a decimal. You're just going to leave it as is. So notice if I start at the center and I count about 7.4, 7.5 in each direction. So 1, 2, 3, 4, 5, 6, 7, super close to each of my vertices there, but that would be the focus there on either end. Okay, so let's graph a few more of these. Example 2, draw the graph 4x squared plus 9y squared equals 36. Again, we want to put this into standard form in order to graph this. So standard form means that it's equal to 1. So if we just take this and we say, well, it's equal to 36 right now, so let's divide everything by 36. And we have to make sure if we divide one term, we divide all terms. And then we simplify. So 4 goes into 4 once, it goes into this 9 times, and that would leave me with just x squared over 9. Here in the middle, 9 goes into 9 once and into 36 4 times. So this is y squared over 4, and now it's equal to 1. That's perfect. Now I can identify the pieces. So notice the center. Nothing is being added or subtracted, so our center is at 0, 0. Okay. Notice the larger value sits underneath the x squared again. So this must be related to our major axis. That must be a squared. If a squared is 9, then a is the square root of 9, which is 3. That means that this guy must be the b squared. So if b squared is 4, then b is equal to 2. Okay, that's enough information to go ahead and graph this. So we graph the center at 0, 0. And again, this one's going to be horizontal, so I'm going to go 3 units to the right is my vertice there, and 3 units to the left to calculate that. And then my b value is going to be up and down, so I'm going to go up 2, and I'm going to go down 2. This right here is going to represent, and again, we'll do the best we can. Oh, that one's a little better. That would be our ellipse. Okay. The last two very similar, but notice that we're going to have to complete the square to put this into standard form. So we're going to take the pieces. There's my 2x pieces. We did this a little bit with our circle equations. So I'm going to leave space for that perfect number. Then I'm going to put down my y values. So 25y squared, I have plus 50y. And I'm going to move that 164 to the other side. That makes it positive. Okay, again, remember that we need a value of 1 right here, so we actually need to pull out the 9. And we're only pulling it out from the x pieces, because we're working with each of these individually. So we get x squared minus 36 divided by 9 is 4. Still going to leave that space there. Over here we have a 25 that's in the way, so we're going to pull that out front, which would leave the y squared. If we divide 50 by 25, that gives us 2y. And again, we leave space for that perfect number. From there, we need to add in those perfect numbers. So again, we take half the middle term. Half of 4 is 2. 2 squared is 4. So we're going to add 4. Now remember, when we add 4, we have a number out front. So we really added 4 times 9, which is 36. So to balance this out, we're going to add 36 to the other side of the equation. Here in the middle, with our y values, half of 2 is 1. 1 squared is 1. But again, remember, there's a 25 sitting out front, so we really added in 25. So to balance that out, we need to add 25. Then we go ahead and factor. So in this case, we've got that 9 out front, and this becomes x minus 2 squared. This one has a 25 out front. We get y plus 1 squared. And when we calculate all of that together, it ends up being 225. Okay. Now again, we need this to equal 1, so we're going to go and divide everything by 225, each of these terms. And then we're going to simplify. Now this on the right-hand side becomes 1. That's perfect. Here we simplify. 25 goes into 25 once, and it goes into 225 9 times. Okay, so we're going to end up with y plus 1 squared over 9. We simplify the coefficient on the x term. 9 goes into 9 once, and it goes into 225 25 times, so just like we said on that last piece. So we have 25 left on the bottom. Okay, again, now this gives us all the information we need to graph. So we need our center. We look up and find our h and our k. So our center here would be 2, -1. And then lastly, we need our a and our b values. Notice again, this one's the bigger value, so this one's going to be horizontal. right? And that must be related to the a squared. So if a squared is 25, then a is 5. And if b squared over here is 9, then b must be equal to 3. So again, we plot our center. We go over 2, down 1. There's the center. And then we count with our a value. So we're going to go, again, this is horizontal, so our a value is going to the right. 1, 2, 3, 4, 5. Puts us out there at 7. And then we count 1, 2, 3, 4, 5 in the left direction. Okay, it puts us there at -3. And then the b, we look over and our b was 3, so we go up 3 units from the center, and we go down 3 units from the center. Okay, and then we go ahead and connect those, and again, doing the very best we can. Sometimes it helps when I turn my paper, but well, it's a good try. The last one's very similar. This one will actually result in a circle, so I just want to show you this. I'm not actually going to plot it, but notice if we look at this one, again, we would break this up so our x squareds are together, or our x pieces, so we have minus 12x. I would leave a blank spot, then I would pull down my y squared and my 4y, and I would move the 41 to the other side. Again, we fill in those pieces, so half of 12 is 6, we square that and we get 36, and then we keep things balanced by adding it to the other side. Half of 4 is 2, we square that, we end up with 4, and again, we keep things balanced on the other side. We go ahead and factor that, we get x minus 6 squared. We factor our y trinomial, and we get y plus 2 squared, and that's going to be equal to 81. Now, again, we could go ahead and divide the 81, but notice this actually is the equation of a circle. We already can look at that and say, well, there's my center HK, and that's just r squared. Again, if you didn't recognize that, no problem. We would divide 81. We would divide 81. And you would find yourself asking the question, well, which one's the major axis? Is it going to be under the y or under the x? And when you look at it, they're exactly the same. That's when you know that it's a circle. So again, the center here would be at the 6, -2, and your radius is what you need to graph this one, is the square root of that 81, which is 9. So we would plot that center, and then we would count 9 in every direction, horizontal, vertical, and then we would connect that.